All right, so we're gonna do this one comparing these most basic, most acidic. You're gonna have to just use cardio. So there's a lot of them. Here's what I like to do. I like to try and identify first if it's okay. What's the most basic? So they're gonna put like two or three that are definitely more basic than the others. Off rip. Oh, do not want blue. This, this, this off rip, I know we're going to be the most acidic. I mean, most basic. Here's why. We said if it's more negative, it's more basic, right? Um, and hold on, okay, charge. All these are going to be charged. All these are going to be charge comparison. The reality is that a carbon ion, or carbon with a negative charge is going to be extremely basic. Very basic. Now, the question is, of these two, which one is the most basic? And I will tell you that the alkane with a negative charge is going to be more basic than the alkyne with the negative charge. A lot of that has to do with pKa, and I only know that because of experience, but the alkane is a lot more basic than the alkyne. It's just more reactive, right? Then so this is one, then we have two, and then we got to find the third. I said nitrogen is one of the most basic because when you look at oxygen, nitrogen is, hold on. Okay. Nitrogen is going to pull off a hydrogen way easier than any of these. A lot of it's because it's pKa. Let me think of how to explain it more outside of just pKa. Also, nitrogen with the lone pair it's very basic. When you work with it, if it's got a lone pair on it, throw it up there with some of the top ones. So we got 1, 2, 3. So now we got our oxygen molecules, right? I would say that this one and this one are going to be the next two most likely, and I'm saying that because these have a little bit of an issue. There's some resonance here, which is kind of gonna jack up the basicity, right? If there's resonance, then it's gonna be a little less basic. But okay, so let me explain this resonance. Okay, so remember we said withdrawing electrons means you're more acidic, donate means you're more basic. Well, this one is going to donate electrons to the ring, making it basic in relation to this one. But this one has a lot less resonance, right? So this one has a lot more resonance, so it's going to be a little bit more acidic than this one. So this one right here is going to be number 4. This should be number 5, simply because there's a little less resonance, right? So we have 1, 2, 3, 4, 5. Now we need 6 and 7. I'll tell you off rip, 6, 7, 8. Here's why. 6 and 7 both have some good resonance, right? So they're a little bit more acidic. There's also not a lot of other stuff going on. Like, hold on, let me show you. This is very electronegative, which contributes to acidity. That makes it more acidic, right? So comparatively speaking, 6 and 7, 6 is going to be more basic than 7 because 6 doesn't have that fluorine on it. That fluorine brings down the basicity of 7. right? So that's why 6 and 7 are the way they are. Then 8, bromine is going to be last because bromine it's really big. Hold on. Yeah, it's bigger, right? It's big and there's nothing else on it. There's nothing else it can do. So that's going to be last. Hopefully that made sense. These are probably the more difficult acid-base questions because you got to compare a bunch of them. But I like to work in groups. I like to work in groups of 3. So first, when it comes to like, if I'm trying to find the most acidic, most basic, I find like for example, if you want most acidic, I figure out what are the 3 most acidic. And I figure out what the most acidic is and I go from there and then I just work in groups and it just makes it easier for me. So that's how you use cardio. And this is covering charge. That's how you use cardio to list the most basic or most acidic, least basic or least acidic.